welcome to a special episode of Dairy Digressions, the new podcast of the American Dairy Science Association, the Journal of Dairy Science, and JDS Communications. I am Matt Lucy, editor-in-chief of JDS Communications, and I'll be your host. I'm coming to you from the 2023 annual meeting of ADSA in Ottawa, Canada. This global gathering of dairy scientists convenes every year and brings together the top minds in the industry. For these special episodes, I'll be sitting down with the experts who are attending the meeting to get their thoughts on the meeting, the sessions, and exciting new developments in dairy. If you enjoy Dairy Digressions or have any feedback for us, please let us know at adsa@adsa.org. Make sure to like, subscribe, and rate us on whatever platform you are listening on, and spread the word to a friend or colleague. And now, let's get to the meeting. Today, we have with us my very favorite geneticist. Can I say that now? I've alienated all the geneticists. Filippo Miglior. I hope I said that correctly. And of course, everyone knows he's our favorite Italian, hailing from Milan, Italy. And Filippo did his undergraduate education, earning his laureate degree in animal science from the University of Milan, and then subsequently moved to the University of Guelph to receive his PhD in 1994 in animal breeding. And apparently you spent a short time back in Italy, an R&D director of the Italian Holstein Association, before moving back to Canada, taking a position as a research scientist with Agriculture and Food in Canada. And during that time, you became an adjunct professor at the University of Guelph. And he told me that adjunct professorship allows you to have students, maybe teach some classes. You teach some classes there?
Lead research, most research and mentoring grad student. Training and mentoring.
Training and what?
Mentoring.
Mentoring.
Yeah, my Italian accent is going to be strong.
Oh yeah, well, I know the mentoring involves fine wine and cheese, of course, and we might get there. I don't know. Cheese is a dairy product, right? And we are good with that. Of course, Italy is famous. Now I don't know Milan. I know the Parma region, but I don't know. Are there many? Milan is kind of up north, but that's not in Parma.
No, Gorgonzola cheese.
Oh. See, I knew there was something there. Anyways, we're carrying on. We're not digressing yet. Okay. We're not going to digress yet. So he returned, he became Chief Research and Strategic Development at the Canadian Dairy Network in 2013. And I guess you were there till 2019 before taking a position with Ontario Genomics. Okay. And then I believe in somewhere around 2020, that's when you returned. You joined Lactanet as a senior advisor, genetic strategic initiatives, and I believe Lactanet came from the CDN. Is that correct?
CDN and DHI.
So those two things. Yes, and you said that Lactanet in Canada is like combining DHI and CDCB in America for Americans.
Very good.
Stick them together.
Yeah.
And that gives you Lactanet.
Yes.
And so you've been with Lactanet since, I believe. Yes. And of course, we know you as a renowned scientist and geneticist, training many students, receiving the ADSA Lush Award in 2014, president of the EAAP, past editor, senior section editor for the Journal of Dairy Science, editor-in-chief for the Canadian Journal of Animal Science, writing extensively, and our latest member of the JDS Club 100.
Correct.
Which means you have published 100 papers in either the Journal of Dairy Science or JDSC, which is a lot of work. Given those darn reviewers, right? They make you work. No, have you ever had a hard review in your entire life?
Very much so. From the very first paper that was published on JDS, which was barely rejected, almost rejected.
Your first paper? They tried to stop you there, go back to Italy and stay there?
And my advisor said, don't take it personally.
Good advice, right?
Perfect advice. I said, they only want you to improve your paper. And that's
and as a recent member, I will echo that. You know, you need to publish, you need to go through peer review to improve your science, right? That's
Correct.
one of the ways.
Correct.
And you're going to get some papers rejected and you're going to get busted up. But if you never go through that process,
Yes.
your science never gets better. You have to figure out what other people see about your science, you know?
Yes. And I review a lot of papers too.
You review papers too?
Yeah, of course. And everybody please review papers because that's what we need. Right?
Yeah, we do need. We need people to go out there and spend the time and spend the time in peer review and do that, you know, and to keep our, you know, just keep our institutions strong. So for the Lactanet, now we are going to get into your research program in depth a little bit later, but it says you're a senior advisor, strategic genetic initiatives or something like that. Does that mean you do secret stuff? Are you trying to maneuver the Americans so the CMEX semen comes into America? How does that work? Are you trying to be smarter than, I don't know, John Cole, or what is it? Hi, John. What is it? How does that work?
Let's just say a few things here. First of all, CMEX semen already comes to US in plenty, which is great. It goes on in many other countries. Yeah. So, I mean, my role is really to, what I've been doing also all along, which is to try to anticipate the needs of the industry and trying to foresee these things that come up in the next few years. So whatever we use today is because research money that we invested 10 years ago. Yeah. And we're going to talk about that in a second. So I'm good at that, just trying to meet those unmet needs of the industry. So when you say who comes to you, who calls you up in complaints, or who calls you up and says, when are you gonna, who are they? Farmers? Are they industry professionals? All of the above? Politicians? I don't get any calls, thank God.
You get emails,
but you know, I'm still a scientist, a strategic scientist, whatever you want to call it. So to me, it's like, look what's going around and what can be helpful for the Canadian industry and have an impact. I always work on applied research. Yes. So I never like to do too much of academic stuff. I always thought, let's have an impact. Yeah. Is this going to benefit overall? Yeah, the industry, the producer, and possibly the society, which the new group of studies we're doing that's will impact that as well. So that's interesting, because when you see you at the meeting, you know you're Italian, and when you look at you, you probably think, well, he must be like a math guy or something. You come up, but then you're so personable. I guess it makes sense that you enjoy sort of the more applied side of the equation, and sort of that's kind of where you're at, is the more applied side. How can we make this all work? Yes, I always love to see something that I know will be used, and I've been lucky, or I guess strategic, that any work I've done has always been being implemented by the industry. Yeah, it's true. It's really true. So one of the things I will say, as being a somewhat frequent speaker in Canada, it's a phenomenal place to go speak. It's a phenomenal place to meet with veterinarians and producers, because I think the average herd size is smaller. Yes. Because as you know, with the quota system, but I don't know if all our listeners understand this, you have to buy the right to produce milk, but then the government controls the price of milk to a certain extent to make sure that you're not going to starve, or starve isn't the right word, but you're going to be able to run a business successfully. And so the farms are smaller, a lot of robotic dairies, a lot of technology. It's a really fun place to speak and to meet people. Yeah, you said it earlier, right? 50% of our farms are in Quebec. Yeah. And most of these farms would tend to be family-run farms. So with a probably average herd size around 60 to 90 cows per farm. As you move to Ontario, the size gets a little bit bigger, but also a lot of family herd run farms there. And as you move west, those tends to be larger farm or freestall, more robot moving along, because of course difficult when it's not a family farm. getting the people to work in the farm is difficult. So lots of robots, for example, in Manitoba, in the prairies, almost 25% of the farms there are robot herds. So it's really very successful. So it's a more, we don't have these massive farms that you guys have down in, for example, in California and so on.
Yeah.
So allow us to maintain a more, kind of that passion of the producer closer to the cow and so on. And
it's really nice to see, I was on farms in the Fraser Valley, for example, or some, and in Ontario. I never forget the farms in the Fraser Valley in BC. Shout out to our UBC people, right? And hi Nina, hi Dan, so the shout out to our UBC people, but and I remember some of these farms, they had robots, they ran robots, they also had robotic feeders, the Lely cafeteria system, but boy, it's a different thing, it's a different feel.
Yes.
It's a different feel on those farms.
Yeah, and allow us to have a non-competitive environment. So like Lactanet is a DHI plus things, and we don't have any competitors. So is a not-for-profit company, and we serve the farmers. We do field services, we do collect milk recording and so on.
Yeah.
And we do also traceability for the government, and then we do genetic evaluation. So it's a very cohesive industry that work out very well for us.
Yeah, beautiful. Yeah, fantastic industry and something to be very very proud of. Now, what percentage of your farms are on test? We call it test.
Yeah, so let's make this clear. This unfortunately went down in the last few years.
Okay.
Because, producer invest in certain technologies, say, what is the added value to still be a member of DHI? Some are still seeing the benefit, thank God, and we're probably around, I don't want to, between 60 and 65% of all the farmers in DHI. But as we are moving closer to work together with, for example, the Farmers of Canada, which represent all producers, we're trying to serve also those non-members, because especially with genomics, you can do that, right? If you do genomic testing, and we do an evaluation. So they are working on those type of area as well, so that even if you're not in DHI, you can still benefit from our services.
So you must, so this is interesting. You bring up genomics. Okay, PhD 1994. I think the human genome sequence came out in 1993, as I remember. Maybe it wasn't somewhere in there, right?
Let's be careful with this statement.
Right. But you've seen it all the way from probably 94. Let's see. Okay, so I was at Monsanto then. Yeah. So you've seen it all the way from benchtop sequencing, right? In one lane at a time in the lab, DNA sequencing, reading one short read at a time, to where we are today, where I don't know if it's true or not. I read it in Horde's Dairyman. Thank you, Horde's. But is it true that the dairy cow is second only to people in terms of the amount of genomic testing, genetic tests? Is that true?
Oh, that's a good statement. I would believe that's probably
true,
reality,
right?
Probably true.
Anything that, remember, we got a lot of young people here. We're hoping, and young people, and you're young too, but young people, what do you think about all that? Going from for DNA sequencing 200 bases at a time to where we are today. Anything that any advice for these people that are probably going to face?
Yeah, genomics has revolutionized the industry, right? Right now, we share the genome between US, Canada, UK, Italy, and these are close to over 7 million animals genotype among all these, of course, with the largest parts coming from US. And the amount of information that we have and we can use, and we are exploiting that information, is amazing. So you have, one thing is knowing just as a black box what is the genetic work for this animal. One thing is when you start dissecting, opening the black box, and seeing all the potential. So the next steps will be looking at closer to your expertise. So what are the physiological pathways? What are the metabolomics path? Whatever, so that we can get closer to causal variants and causal things. So that, but for now, it's working very well. So the genomics. For us.
No, it's fantastic. And I think that's one thing I would say to young people is that, and I imagine you would agree with this, if you want to be in the game, you got to be able to handle big data.
Yes,
okay. So I know you're going to, and you can do it with an Excel file. Okay. You need to learn how to real people handle real data. Right. And And right?
Yeah, and we have artificial intelligence that is starting to helping us, right?
Right.
Our latest product, which is we're using milk spectral data to predict methane. We've been using an artificial neural network approach, which allows us better prediction accuracy, and we've been successful. So, and we have so much data we cannot handle anymore, or even see patterns in the data. So we need to have this type of technology for sure.
So the artificial intelligence to have, and but so we talked about that yesterday. Well, I was talking about that with somebody. Here we go. Now you say AI, and now I think the world thinks no more artificial insemination. They stole it. They co-opted. I'm going to go to my farm and do AI, and they're like, "Well, what do you mean, breed a cow or what? What are you doing there?"
I was just talking at lunch with George Dick, which is a producer from DC, who's going to talk tomorrow.
Oh, fantastic!
You're going to enjoy it. It's part of our symposium tomorrow. And we're talking about that, like, it's just also overwhelmed by the data that it's getting. Say sooner or later, it's going to have an AI within the farm to manage those animals and making decisions based on pattern we cannot see anymore.
Right.
And even for us, maybe they're small, but when you accumulate the type of data, at Lactanet, we sit on 3 billion data points.
Oof.
So how can we? And we're starting using that data. How can we? And then we can say, well, what, can we use the data together with the processor? Right? So all this type of potential data out there with this amount of data.
So again, for our young people listening, we hope if you enjoy math, if you enjoy science, if you enjoy biology, if you enjoy data, this is an area.
Yes.
And you can go into dairy and you can have a career that will be exciting and will make a difference. And there's no question.
And I am a city boy. I grew up in downtown Milan.
Oh, well.
And I know whatsoever link to dairy farming. And then I went to my professor in genetics and say, hey, I want to do the thesis here. He looked at me. I didn't have a big muscle, but my thesis was to go and weigh cows before summer pasture in the Italian Alps, and then after the summer pasture. And then you get so much affection to this industry because it's a great industry, great people, and then the science below is just have so much impact. And let's talk about, we're not doing any manipulation of genes here. We're talking about selective breeding. So we are only use genomics to identify with more accuracy who are the best.
So since we're digressing, we're going to digress now.
Let's digress.
This is dairy digressions. First thing, okay. Are you ready?
Yeah.
Okay. I big data.
Yes.
Okay. And the first roadblock to big data is getting all this data into a format we can use it. All the data coming off the collars or off the robots, and you got D-Laval robots and Lele robots and SCR collars. How does your organization, Lactanet, do you have contracts with those companies to get their data, or how does that all going to work in the future?
So there is an initiative which is called IDDEN, IDDEN.org, which pretty much groups 7 founders. One is Lactanet, I think there is US as well, and then other Europeans. And the objective is to have one common interface with the manufacturer.
Okay.
So the Lely, the Delaval, or the Alflex, whatever. So that say, let's have one standard so to get this data and possibly sharing the data as well. So that is just started, but we have lots of confidence that will really help us as an organization. We'll help the producer. We get this producer that buy a lot of this new technology. We say some are gadgets and so on, but some are very useful. Activity monitor, you're very aware, of course, all this type of thing. Can we use that even more to benefit? At the end, we want to make our dairy farming more profitable, more efficient, more environmental efficiencies.
Right. And I know I used to consult with D-Laval, and I used to look at a lot of robot data, and the amount of data that comes off a robot, it ain't just milk production. It's a lot of data comes off robots, and you just can't, it's like you said, you need to use the artificial intelligence to do it. And I think, unfortunately, we were at the editors meeting yesterday. Everybody's worked up about ChatGPT and computers writing text. And okay, but let's not throw out the baby with the bathwater here. I mean,
Yes.
okay, there are aspects of it that are
Yes.
tricky and we have to navigate, but there's other parts of it we need.
Yes,
You
and
know,
we are
we
using
need-
also as
We
animals,
need,
right?
yeah,
So,
yeah, and so it's important. So I'm not, we're not going to digress very long on this, but, and if you don't want to discuss this, you just say, let's just not talk about it today, but, do you think genetic, okay, so they've got new words for it, gene manipulation or sort of a
gene editing.
gene editing, humans editing the genome of a cow. Okay, so I know this is a hard one and you can't probably say, but do you see that as something that your organization, you're probably looking at it, but do you see it as in the future for your organization?
Yeah, so let's say a few things here. So it's the fact that we only work from selective breeding, so it's we don't manipulate any genes. What are the potential gene edits? The problem in animal science has always been there's been a double standard between animal science and plant science,
Right.
in which somehow the plant have been allowed to do genetic modification, and they've been ostracized now from Europe and so on, but they've been used. Like we have found lots of crops that have been GMO. And the animal has always been a double standard, so there is somehow the animal is closer to our.
It's a mammal, right?
It's a mammal, so we think, what do we do about? So I think is a technology that can change many things.
Yeah.
Are we ready for it? Let's see. Will be interesting to see when that technology will be, if approved. Yeah. Fully, not just on a temporary basis, and what we create. I know that I was just in Parma, where there is the European Food Security Agency, and they have to start looking at those things because the industry are pushing for this type of thing. So we, as always, I would say, let's see how it goes, but monitor and let's understand that everything goes well. There are no side effects, no side impact on other things. So.
It's always I think one of the things, it's also you set that against the backdrop. Well, there's two things that you set it against the backdrop. First of all, we make tremendous progress with just traditional breeding and genomics. So things are moving fast right now. I would put that out there. And the second thing, you kind of put it against the backdrop, is that there's probably some low-hanging fruit in terms of genetic modifications you could make, but the vast majority of the traits we work with are multi-quantitative traits and multi-loci, and it just gets a little bit tedious to try to do all this stuff, and then of course you just don't know what'll come in terms of markets and stuff if all of a sudden your cows are modified and this other nation's cows are not, and consumers. So it gets a little. So more on that later. Probably not ready to talk about that today, right? So
I was quite diplomatic.
Yeah, you were very good. Yeah, you were very good. So I'm an old Monsanto guy. This is the nation that wouldn't purchase bovine somatotrope, and I won't bring that up. I won't say anything about that. Okay, but back in the day at Monsanto, bovine somatotrope and Canada really held the line on it. Their producers were not allowed to use it. Their consumers didn't want it, and you guys held the line. And for us, it was a very good product, but in the end, it's not used in America either. And so at this point in time, so fair enough. So the local dairy scene, I think you touched upon it, and the local dairy scene, you touched upon it, and what? Okay, so what are your guys? What are they looking for? What are your constituents looking for in 2023?
Yeah, so this year we were the first in the world to launch our genomic evaluation for methane efficiency.
Really?
Yes.
You stole that from the Americans, didn't you?
I've been pushed with the Americans to work on this for 10 years. My research has always been open. I've never done anything secret. Yeah. And this very much applies. So 10 years ago.
You got an evaluation from methane?
Yes.
I
April.
completely missed it.
That's okay. We are here for that, to
Oh,
educate people, including yourself.
Yeah, right. That's why we do dairy digressions.
Exactly.
You gotta tell me about that.
So,
It's a trait.
Yeah, it's a trait that allows the producer to reduce methane production without affecting production trade, milk production trades.
Right.
Because obviously you probably know that methane production is unfavorably correlated with fat in particular.
Right.
So we have to be careful if we want to select for one not to affect the other. And
Yeah.
we have been able to do breeding evaluation that allows to decrease methane production, but genetically independent from fat, protein, and milk yield.
Yeah. So this is for our listeners, this is just incredibly important, right? So sometimes sometimes you have a trait which sounds really great. Yeah. And so for example, heat tolerance. Okay, yeah. Heat tolerance sounds great. Okay, yeah. But we saw today in the session, and it's well known that if you select dairy cows that are heat tolerant, you're also selecting for low production dairy cows, which makes sense, right? And I'm not sure how. I know the Australians, and Jenny Price is a good friend of the program, and I know they have their heat tolerant thing, and I'm not sure how they handle that, or how they've got that handle that, and maybe they've found a workaround for that. I don't know, but heat tolerance is an example where you select. I can give you a heat tolerant cow. Just give me the worst cow in your barn. She's probably going to be pretty heat tolerant, So, but now what you're telling me is you were able to figure out. You were able to design. I don't even know what the words are. Genetic evaluation for methane production without impacting milk production. Okay, so first of all, that's almost impossible. Okay. Second of all, because you need genotypes, which is easy, but you need phenotypes.
Good.
Where did the phenotypes come from?
So back in 2012, I went to a thesis defense. I was an external for a PhD defense. Actually, 2008, this one in Belgium, and Dr. Nicholas Gengler group, and was working on milk spectral data, which is, is this data coming out of our spectrometer, from, where you send your 50 milliliters of milk to measure fat and protein percentage. And by doing that, it create a new phenotype, which is based on absorbance of this spectrometer. And Dr. Nicholas Gengler's team showed that you can use this phenotype to predict other traits. Fatty acid was one, and then BHP, which are indication of subclinical ketosis, and all other series of traits. And I went back to Canada and said, guys, this is something we need to start collecting data, because this FOSS machine, they create this data, but doesn't save it. So you needed to save it and store it. And so we start creating the pipeline. We start in 2012, 2013. And in 2018, that's when we had pretty much 90% of our milk recording animal, this data for those cows. So that created this historical database, which I knew was going to be helpful sooner or later. And so this was investment in money, by the way. This was research money from the industry. And at the same time, we had a series of other projects, the Efficient Dairy Genome Project, which was funded by Genome Canada, which I led for the first 3 years, and was about the phenotypes. You see, those are expensive phenotypes. So we say, okay, US, Canada, Denmark, Australia, and Switzerland. Let's put this data together from research herd, and and we can use them for genomics. Because now genomics allow us to. You don't need to measure this data across 10,000 herds. You can just measure in a selected group of herds. So we put this data together, and the outcome of that project was that we were able to do feed efficiency evaluation in the US, in Canada, in Australia, in Denmark, and so on. So allow us to use that reference population, because you can imagine measuring feed intake on a cow can cost between $500 and $2,000 per cow. So those are very expensive. But we also started collecting methane emission, in particular in University of Guelph, University of Alberta, and we started collecting this data and matching them with the milk spectral data. Now,
brilliant, right? And
using the milk spectral data, we can have a prediction of methane production. Now, let's make it clear. There is no methane in the milk. So by just based on the fatty acid composition, you can have a good accuracy prediction, accurate prediction. And so we have been able to do that, and was quite accurate. and we say, well, let's do it. And we work together with CIMEX in the last year exactly to accelerate this.
Yes.
Because that's the thing, we need to start decrease methane emission. We are not the first. Definitely, we're not the first culprit in guilty of this, because dairy will represent only 1 to 1.5% of GHG emission in Canada, and US maybe it will be very similar. But can we help? Yeah. So why not?
Yeah, this is a great story, and you touched upon so many important things, and you talked about the spectral analysis, the FOSS analyzers, and I don't think people. Well, you knew it, and I learned it later, but that, you send in your milk sample for FOSS, and they're only, it's analyzed on a spectrophotometer, which means they collect data across probably 1,000 wavelengths. 1,000 wavelengths, but they only use a few wavelengths for fat and protein, and all the other data just sits there. But FOSS, and I think they're the only manufacturers of those, or maybe some.
No, there are other.
But they're the main ones.
Yeah.
And they were dumping all that other data, and then you had to just say, hey, instead of dumping it, can we capture that data? And people said, wow, there's a tremendous amount of information there. And then to be clever enough to just basically say, okay, well, let's get some hard data on methane, but then let's try to correlate it with these analyzers, because then you can use the milk analysis, and then you got cajillion cows that you can phenotype for methane, right? And then develop this I never know right words. It's a trait. Is it a trait? What do you call it?
It's a proxy, I would say. I always call it a genomic evaluation for methane efficiency, which is based on milk predicted methane.
Milk predicted
methane. Not methane, it's milk predicted methane.
So you have this milk predicted methane, okay? And again, you guys are smart enough to know that we can't introduce a trait that's going to knock this knot out of our, because we talked about methane yesterday with Jeff Firkins, and he said, yeah, I got an easy way to reduce methane, make a higher production cow. That's what he said, right? You can have a higher production cow, and your amount of methane per milk produced goes down, because a big, huge, high producing cow is more efficient than 2 little low producing cows in terms of methane. But what you're telling me is you were able, through genetics, you actually have a cow that is more efficient in terms of her production of methane. But then what have you done to that? And this is the problem with you geneticists. I'll tell you right now, you do the stuff for the cow. You don't know what's going on. Are you collaborating with the nutritionists to say, hey, are these elite cows? Is their rumen different in some manner? What is different about them?
You touch many important points. So,
First of all,
rumen. Let's make this clear.
That's
the methane is created by the rumen microbiome,
right.
But we also know that the host, the cow, controls in large part of that microbiome.
Yeah.
You know very well there has been study in which they emptied the microbiome of the cow, put the new microbiome, but after a month they revert back to the original.
You know more biology than most geneticists. Look at now, I'm in trouble. Now they're all going to be calling in.
And they're going to redo this test again. I know that. I heard about they're going to redo it again.
Redo the test where they took the microbiome. Okay.
And it
so
goes
carry on. Sorry.
So, and that's okay. And that's important. But we know it's easier for us to work on the host than on the microbiome.
For sure.
Because it's also less invasive. Microbiome, you have to, put things to get the rumen liquid and so on. So anyway, doesn't work very well. I know some countries are doing that, but we decided just to go on the cow.
Yeah.
And we can tell you that this methane efficiency is a new trait once it's been corrected for production. So it's really not related to any other traits. And we evaluate over 100 traits in our portfolio. Okay.
Yeah.
And there is no unfavorable or even significant correlation with any other traits.
Okay.
So one of the great things of selective breeding, as long as you monitor and collect data on health, on fertility, on production, on longevity, on on other feed efficiency, for example, you're gonna change some of these correlation among those traits in a way that you want, because at the end you're gonna choose a bull that produce a lot, that it produce less methane, that is more longevity, that is more fertile. Boy, talk about the doctors, of course, and more healthy. So bit by bit, you move the genetic structure of the population, and in a natural way,
Right.
not in a immediate, modified genome way.
So, and so, as Filippo said, I mean, it's an excellent understanding of the biology of the entire situation. The biology of the entire situation is the host, to a certain extent, dictates the composition of microbiome. We learn that. And furthermore, that it's very difficult to through. Okay, now the probiotic people are going to get mad at me, but if you're going to do probiotics to move the microbiome in the rumen, they got to get the probiotics.
Let's talk about that.
Daily. No, we're not. We can't talk about everything.
No, but because it's important. Because I always say genetic doesn't work on its own. You always need genetic can express if you have a good management, right?
Yeah.
I always say it's like a Ferrari. I have a beautiful Ferrari, but
is that an Italian car?
If Matt drives it, it's not gonna be good. If Filippo drives, it's
gonna be awesome, right?
No, but you need the right driver, the right manager, right? So, and the genetics works well in those farms that they use the right. You can have fabulous genetic, but if the producer is not good, is doesn't do a good job, it's not the genetics not expressed.
Right.
You're not gonna solve fertility problem with genetics. You're gonna solve it with genetic and management. The nutrition is very important in this aspect. So our new Genome Canada proposal is looking both at nutrition strategies, genetic mitigation strategies for reducing methane, and the interaction between the two. Because I talked about microbiome, but another important aspect that really modified that microbiome is the feeding system, right? So, so that's important to be able. We know there's been a lot of launch of, and I have to be careful here, but of additives, that are not allowed in Canada, by the way. They're not approved in Canada, no.
Okay.
And they say, oh, you get this amount of the reduction. It's not, and that's great. But in our project, we decided not to work with this additive, but just to work with natural feeding system. We have, Canada. We have it's a massive country. We're different from BC all the way to Atlantic Canada with different feeding systems.
It is a big country.
So we can find what is the best, and we estimate that we can reduce methane emission without additives by 2050, just with nutrition strategies only by 40%.
Is that right?
If we add genetics will do 20 to 30% by 2050. The two things are not, there is some overlap, obviously. So we believe we can reduce methane emission by 50%.
Wow.
Yes.
That's amazing.
Yeah.
Through science.
Through science.
Okay.
Yeah.
Everybody got that?
Yeah.
Science matters.
Yeah. And
that's how you solve problems.
Another important aspect.
Everybody know that.
Another important aspect is mixed spectral data, not just individual anymore, but now we're thinking about using milk bulk test.
A what test?
The bulk milk, the one that
the big silver thing.
The big silver thing. Where each producer they put their milk. And the truck comes and pick it up. And based on that milk sample analysis, they are paid, right, on milk pressure, fat, and protein percentages. That we can use possibly that data to also quantify methane emission as well.
On a farm level.
Not now, but that's what we're working on. By doing so, all at once, you're able to access not just your DHI members, but also any other dairy producer, because they're doing that, because they need that for milk payment, right?
Right, they have to have it tested.
So that will be a really big change, and we will allow to quantify and to benchmark anonymously, of course. We will never publish this, but who are the farms that are low emitting farms? Who are the farms that are high emitting farms? What these low emitting farms are doing? What type of feeding system they're using? What type of genetics they're using? Oh, we can teach, we can transfer that knowledge to those and push those other higher emitting farms to do better.
Yeah, I think this is so important. And I think, this is, I don't know who will listen to this podcast, but maybe somebody out there in podcast land will listen and understand that, we, the dairy industry, we're not running away from methane. We're not denying methane. No. We are actively and making solid progress. I mean, 50% reduction, in methane emissions, and I teach dairy science and I always tell the kids, everybody complains about methane from cows, but there's actually more methane leaking out of gas wells, because these guys don't tighten up their nuts and bolts,
in our kitchen.
Yeah.
The gas cook stuff.
Yeah, and so there's other ways to reduce methane, and we all got to work together on this. We can't beat each other up, and methane reduction, enteric methane, and of course, as you know, in America, the greenhouse gas, the greenhouse capturing the methane, natural gas, biofuels. That is moving.
Yeah.
The needle is moving on that. Now you need a very, very big dairy. My understanding is a very, very big, you need 3,000 cows to make one of those things work. But nonetheless, if we all work on this thing, we can make progress. And again, I just emphasize that progress is made not by, running your mouth. Progress is made by working.
Yes.
And doing science and figuring stuff out and having ideas, and that's how you make progress.
Yes.
And it's true, right? And it takes time. But
you're not gonna have something that say, hey, well, I guess you have with some others say 50% reduction, but we need to see what is the impact
Right.
in the long term to the cow and to the farm and so on.
Yeah.
But this improvement needs to be incremental, continuous, permanent, and so on. That's
because we
genetic
care,
nutrition works towards, right?
we care, right?
Yeah,
We
of
care.
course.
I mean, and so the two questions: who owns the trait? Okay, is it confidential? Are you sharing it globally? Or are you trying to figure out how you're going to share it globally? Who owns the technology?
Okay, so we haven't invented anything yet. So we're doing something that has been published since 2012. The Patent Belgium were the one publishing. We can predict methane emission using milk spectral data. So, and this milk spectral data needs to be standardized, needs to be treated in a statistical way in order to clean up the noise and so on. But they need to be, on a common scale and variance, right? So you cannot say, oh, let's take the prediction that Canada did and use it to US. That's not going to work because they're different. Also, in your case, you use also other companies, not just Foss, other Bentley and so on. So this data, what we can do is, this is the way we're done, and we publish, as you know, a paper in things. There is nothing secret about what we've done. It's all published on a previous basing previous paper. Has already been published in 2022 and JDS. So there is nothing secret. We are just
but if a country to pick it up, they would need to validate it with their own technology and their own
validate our own things. We know our prediction is not optimal. Okay, but we need to start. Okay, we cannot wait until something is optimal to implement it, because we know, especially genetics, is very forgiving. We know we can already move the population in the right direction.
So one of the things. Okay, so I can't remember what your genetic. Okay, we have net merit. What do you have in Canada? What do you call it?
LPI, lifetime profit.
LPI, your LPI. Okay, LPI is crowded, right? You got lots of traits in LPI. Okay, so you're going to tell this dairyman, I'm going to take some weight off milk and fat and protein. I'm going to put in methane, and they're like, oh yeah, I love the environment too, Filippo. How do you put it in there? There's no space for a new trait.
That's an excellent question, Matt. I love it. Because there are two important points there. One is all the traits in an index, but let's park it for a moment. Let's talk about the producer buy-in here. Okay. So the average producer probably, and I don't want to talk on behalf of the producer, but that's just my perception. Probably right now say, well, what is in it for me? What is going to happen? Is there an incentive? Is my milk going to be paid more just because I'm doing producer less methane? I hope so. One day that will happen. It's not the case right now. We have some carbon credit system in Canada, but they're not yet applicable to the dairy. We need first to quantify, to monitor, benchmark those farms, and then go to the government and say, hey, we have a system in place that is a little bit better than your IPCC, one equation table to measure methane emission. So we can actually tell you which farmer are doing. So maybe we could create some system. In our project, we have Environment Canada. It's going to be a part of our team, exactly, to inform each other on this. And this is the team that brings the data of inventory to the United Nations, right? To make that decision. So going back to the average producer really probably not that interested right now. But if you start telling them, hey, if you reduce methane, it's not just for the environment. It's going to be, you're saving energy. And this has been published, 4 to 9% of energy is wasted just in the methane. We can quantify that more efficient cows, in the Canadian herd, which is 1 million dairy cow, close to $100 million per year. Okay, so that's just in savings.
Right.
If you put the carbon credit, there will be another $350 million.
Right.
So this is not just for, I believe in social responsibility, but it's not just that. It's just the fact that it's going to be savings for the producer. So if we're able to educate correctly and tell the story well, I think that will work. The leadership wants that, because obviously the farmers of Canada, the farmers of America, Saputo, you know, all the big Lactalis and so on, they're working on dairy net zero. Nestle, they're published. These things is available on their website. And so they're all working on that. And so obviously we just need to move. We have now early adopter. Tomorrow you're gonna hear about one. George Dick is fantastic. He's measuring methane emission in his own farm. He's building a new bar just to seal to just measure even better. Wow. And he has a biogas thing. So he's a fantastic producer. He represents all the producers? No, he's one of the early adopters. And it's a classic new innovation. So can we move more and more of the average towards the early adopter? That's going to take time. But producers talk to each other, and they will listen more to another producer than to Filippo.
That's true. Yeah,
and that's okay. That's how it works, right? If you're able to have these early adopters and they show the impact, and they actually save money, they show, hey, this is very beneficial to you guys. Why don't you do as well? Yeah. So going back on the traits, genomics changed all of that, because we have been shown already that we are making amazing progress in milk, fat, protein, and longevity, and metabolism, the whole thing, even if we have 12, 15, 20 traits in the thing, because genomics work, and we're moving, selecting any of the bit by bit are going to be good for all of this. So it just adding that methane, maybe 3-5% emphasis. We have not added yet, but it's going to happen probably in the next within 1 year. It's still going to be already important, because once you put it there, means that AI, not artificial intelligence, but artificial insemination, will use it. And so it means that bulls are already pre-selected for that as well. So the uptake is going to be seamless anyhow. The producer can also decide, can I do a genomic test and see which heifer are better in terms of producing less methane. The early adopters will look at that. The average population will not, the average producer will not, but bit by bit, it will move the population.
It's so right. And, that's one thing I learned about methane early on is it's a loss of energy when that ethane goes into the air. And if you're not losing that energy is going into milk, and so there's a real, that's just an ironclad argument there. That's so
and
solid.
Highly heritable, 25 to 30%.
Oh, stop! No way! High 25 to methane.
It's based on fatty acids. These are very heritable traits.
25.
We can change this so fast if we want.
That's nuts. Okay, so for everybody else, what's milk heritability?
Same, 25-30%. This is exactly equivalent. In fact, our genomic breeding value are very reliable because
heritability is huge. So we're going to wrap up here, but I want to just say a couple things. So I think we've definitely done the last question. Where do you see this science go in the future? We'll just leave it at methane because it's so important. We've talked about the fact that you have a very important symposium tomorrow. Do you remember the title of the symposium? Something about net zero, right?
Yes, I think it's the mitigation strategies to reach dairy net zero.
So a whole symposium tomorrow about that, with invited speakers, with producers.
8 speakers.
8
4
speakers.
American, 4 Canadian.
Good, all good.
We love
good. We love the Americans here in Canada.
Producer or consultant, industry, academic, government, all kind of.
That's going to be packed. That's going to get some.
Let's do it.
Let's do it. Yeah, that's going to get some. So that's tomorrow at the national meeting. And the last thing I'll say before we close, and maybe you could just explain it to me. Is that one of the things about the ADSA national meeting is the geneticists always show up. You haven't, the dairy geneticists, you would never have turned your back on this meeting. All the CDC guys are here. Okay. They're all here. And then I saw we got some new people showing up, some younger,
new generation,
generation. And what is it about the meeting that brings you dairy geneticists together? You're always here. You can always No, there'll be posters and you know where to find you guys.
There are faithful attendees coming. We have a group of Sardinians that have been coming for 25 years to this meeting because they like the food, the dairy focus type of conference. We have a Canadian, they always, this is the highest group of Canadians that come out to an international conference, which is great. We have from other countries, from Southern America, they kind of, so European, this time European, lots of European coming as well. It's because it's the quality, the fact that you get that that exposure not just to the genetics part, but say, hey, there is this interesting on extension on the milk.
Yeah.
And we work on data. So when I work on milk, spectral data, we can also do spectral data to measure fatty acid, to make some lactoferrin in milk.
Yeah.
So at once you start crossing in disciplines, and that's the beauty of dairy science. American Dairy Science Association, the meeting is just everybody works with milk. It's just its own big department across university that work on the same focus, which is this fabulous food and product.
So we're gonna close. We have a gift for you.
Oh no.
Hopefully
not too big.
And just
liquid.
there it is. And you open it from this end. Yeah, you have to open it on camera. You have to open it on camera. These are so exclusive.
Oh my God.
These are so exclusive that
this is forbidden in Canada.
No.
This is forbidden in Canada.
Well, we'll put that back, but there's not many people with these mugs. Okay?
Dairy digression. First of all, fabulous organization.
Oh yeah.
Second, fabulous friend.
Oh yeah, it's been fantastic. And so we're gonna close, and I knew it would be just crazy fun to talk to you, and of course you did not let me down. It's been Dairy Digressions with our guest, me, the host, Matt Lucy, and our guest, Filippo Miglior. And thank you very much for spending time with me.
Thank you so much.